Hello, my name is Scott Mesjian, and today I'll be walking through the figure 3 for week 6 for discussion section 8. In this problem, we have some gas in some kind of piston where we're adding some additional mass, and in this situation, uh, the outside temperature is actually insulated from the inside, so one thing we know that is that the T in is not equal to the T out. And immediately that could be a potential pitfall, right? Because maybe you didn't know what insulating meant. So yeah, that's what that means is that this outside temperature is not guaranteed to be the same as this inside one. Okay, so now what this question is actually asking about is how the pressure, temperature, and volume of the gas change when um, additional mass is added. So one thing you should know is that when additional mass is added, um, that is essentially going to put more force on this piston going down, right? Also, we should write this out. This would be helpful. Uh, PV over T is equal to PV over T. And these are initials, and these are finals. This can help you visualize the equation a little better by just writing it out. So we know that the T in and T out aren't the same, and we know that there's some additional force being exerted on this gas. So essentially, basically, we know that um, if there's more force on this, then this is probably going to move down. So like, let's say maybe it moves to like this level. Okay, well, if it moves to that level, then we can immediately see, well, okay, the volume is already decreased. So we know that the final volume is greater than the initial volume. Oop, I wrote that down wrong. There you go. So that's one thing. So we already know what's happened to the volume just by simply looking at how this additional mass would affect the piston. Okay, good. So now we have one thing down. So now how would that affect the other two things? Well, like I said before, the temperature on the inside of this gas and the temperature on the outside here, for example, are not guaranteed to be the same. In fact, they're not going to be able to exchange heat at all. So when you have a smaller volume for this gas, what's actually going to happen is it's gonna heat up. So um, so we'll say that the T final is greater than the T initial. Um, and that's just because, there's a smaller area, more particles are colliding, and yeah. Um, okay, so we know that. Cool. So now what's going to happen to the pressure? Well, if we look at how the volume and temperature have changed, well, maybe we can find the pressure. So we know that the final volume is greater, and we know that, or that, I'm sorry. I wrote this down wrong. My bad. Maybe I said it right, but I wrote it down wrong. Yeah, oh no. Yeah. So the final volume is smaller. Yeah, I'm sorry, I wrote that down wrong. But yeah, obviously the final volume is smaller in this chamber. But anyway, so the final volume will be smaller, and the final temperature will actually be larger. So how does that change the pressure? Well, obviously just decreasing the volume would increase the pressure, and then increasing the temperature would also increase the pressure. So those combined is going to result in a giant increase to the pressure. So essentially we know now that the final pressure is greater than the initial pressure. So yeah, we found out the relationship between all these elements, and that's the kind of the problem. Obviously, I made a mistake with the relationship between the volume, but I think that's kind of easy to see based on the drawing. Um, yeah, and then you got to remember for the temperature, since the heat can't exchange with the outside, the temperature will actually go up. And then the pressure is kind of evident based on those two things. Yeah, hope that was easy to understand. Thank you.